In problem 10, we are looking at three different functions, and we are finding the inverse for each function. Once you find the inverse for each function, then you need to consider any restrictions that might exist on the domain of that inverse. In looking at letter A, B, and C, how do you find the inverse function? Well, the procedure is the same for all. First, you start off and you state your function. Then you re-express in terms of in terms of f of x, you will use y. For the term of f of x, you will use y, and all three. And then you interchange the x and the y in all three cases, and you solve for y. Here we have y, first you're going to square both sides of the equation to eliminate the radical. And then you're going to move the 2 to the left side by subtraction, and you have y equals x squared minus 2. You want to convert back to function notation, and the notation for inverse of a function is the negative 1 exponent notation. And as you can see, I did the same thing here. Once I interchanged, then I moved the 4 over, and I had y cubed. Take the cube root of both sides, change your notation to inverse notation, and here's your inverse function. And this seems to have been left off. So let me come down here, and I will finish the correct notation for the last one. Alright, so for the last one, it should be, and I'll put it over here, f of negative 1 of x, because I started with the f function, so I'm saying the inverse function for f is 2x plus 4 over x minus 1. Alright, now let's talk about restrictions. Sometimes the restriction has to be carried through to the inverse, and sometimes it doesn't matter. So in this case, we have a radical. And when we have a radical, since we're dealing in the real number system, we cannot take the square root of a negative value. So what would make this a negative value? Anything that would be less than negative 2. So when x is greater than or equal to negative 2, I will have a 0 value or a positive value. So my restriction is on the original function. When I have restriction on that, that means all of my range values for this function will be greater than or equal to 0. They will be all positive values, or they will be 0. Now, consider what happens when you take the inverse. What was the domain here becomes the range, and what was the range becomes the domain. So the new domain for the inverse function will be x is greater than or equal to 0, and that's why you have that answer. Now, in dealing with a cubic function, you can take the cube root, you can raise a negative or a positive number to a power of 3 or any power for that matter, and you will not result in a restriction. So this has no restrictions, and if you're looking at the actual inverse function, you can take the cube root of a positive or negative value, so this has no restrictions, and your domain for your inverse is all real numbers. So that's that explanation. Now, this one's a little trickier. Even though I have a function which would have a restriction on the denominator, x cannot equal 2. That restriction would not apply to the inverse, because the only thing I have to worry about with the inverse function is that the denominator not be 0, so the restriction on the domain for the inverse function is all reals except 1, which would make that 0, or the domain is from negative infinity to 1, exclusive, because you can't include it, united with 1 to infinity. So in other words, 1 is excluded from the domain because it would make this fraction 0 in the denominator, which makes it undefined. So I do not have to carry this restriction to the inverse because 2 does not make this undefined. So the domain is all real numbers except 1.